My name's Matt Bader, and I'm an infrastructure automation engineer over at Rally Software in Boulder. I'm involved in the Puppet meetup downtown at Ping, as well as the DevOps and the Docker meetup in Denver, and also the Boulder one too every once in a while. Today, we're going to give a brief introduction to DockerSwarm. Before we start, can I get a show of hands of how many of you have used Docker before? Okay, and is anyone using it in production right now? Cool.
We intend to when we have a production system.
Excellent, excellent, very cool. All right, so yeah, without any further ado, here we go. What is DockerSwarm? DockerSwarm is a clustering utility for the Docker daemon, written by Docker itself. It was announced at DockerCon 2014 as a POC, and actually I heard about it a couple days before that at the Docker Global Hack Day, which was before Christmas sometime. It was written by Victor View and Andrea Lizardi in Go, and it's basically, right now it's approaching a beta release, but it's basically a single daemon, a single threaded daemon, that will allow you to create a cluster with a bunch of Docker daemons, or a bunch of Docker hosts. You can see this was cut January 24th here, but there is a high level of activity on this repo. It's a very fast-moving project. There are a variety of PRs that are open now. Issues are opening and closing every day. So if it's something that you would like to contribute to, it's a very fun project to contribute to, because you're able to make a contribution, see it in prod, or at least in the next cut release very easily. How does it work? It basically runs, it works in a similar way to Docker. So it runs as a daemon listening on the network port. It then accepts requests on 2375 or 2376 and directs it to the variety of Docker hosts behind it. Now you can apply some logic into how that's directed, which we'll get into later. But for the most part, it's a Docker proxy for interacting with Docker, not for interacting with the services that are running in the containers, but for the actual Docker implementation. It uses a discovery protocol to build the cluster, or it could also use a flat file. But basically, it uses either a key value store or a flat file to create a list of servers, and then of Docker servers behind it, and then health checks to determine which ones are available for scheduling. Amongst the containers, or amongst the backends that are available, Swarm is in charge of scheduling. It does this in two ways. It uses filtering, which is based off of tags and a few other metrics, but filtering determines which machines are available to be scheduled on. Whereas scheduling determines, out of the available machines, where am I going to place this container that needs to go. So in using the filtering and scheduling, that's what differs it from Docker itself. It also provides an interface that is very similar to a single Docker host. So that means that most of the tooling that you use now will still work. So you don't need to swap out anything to manage the cluster. It will work with your existing tools. Now, once you get into TLS, things may change a little bit. What I've found is that the current tool chains do not necessarily support TLS effectively and in a straight Docker environment, let alone a Swarm and Docker environment. If you are in an environment like that, there are ways to get around it. Basically run TLS with no verify, but you may still have problems. The two major differences here, or two other things, it doesn't proxy the net ports. So it is a proxy for creating and destroying the containers. The actual traffic that's running through the application does not run through Swarm. So even if Swarm goes down or is somehow unavailable, the containers it has provisioned are still up and running. The other thing is that it rebuilds its state database. So if Swarm does crash, you're able to fire it up. It will immediately see what is available. It will connect into the service registry as well as health check everything. It gets an immediate picture of the state of the infrastructure right then. So there's no need to sort of persist state off or do anything tricky with that. What I've seen is that running two of these in an active passive mode is a good way to get HA. You're not going to get your full capacity of the two nodes, but since it will rebuild its state BD and it's not proxying net ports, it's okay for the one to go down and then gracefully fail over to the other. One Swarm daemon to go down and fail over to the other if you're looking to set this up in an HA environment. This demo does not cover anything HA at the moment. How does it differ from a single Docker host? Well, it basically provides you a single endpoint to interact with the multiple hosts behind it. So you can say have 10 pieces of hardware, all running the Docker daemon. Currently, if you say want to spin up an Nginx server on each one, you would have to set your Docker host to be Docker host 1, fire up your container, then change your Docker host 2, fire up the container, or whatever. It's very tricky when you do it on the command line. It's just a real pain in the ass. And also, it's tricky when, say, in your build pipeline. If you want to, say, give a pool of resources to your build job, you cannot effectively do that. You can give it one Docker host. That leads into some complexity when creating your job. Say you need to segregate your resources or increase capacity. There's a lot of manual work going in and updating your Jenkins job. This will provide you with one resource that you can point any number of build scripts or build jobs or whatever at, and it will operate just as if it were a single Docker host with a few minor differences. Each Docker daemon that is running on the physical host or whatever in this cluster is actually started up with a set of tags. You would put, for instance, storage equals SSD or zone equals external. These tags are what the filter mechanism in Swarm uses to determine which nodes something can be scheduled to. And that's part of it. So that's the, I'm sorry. The tags are what bring it in and allow it to be in the filter. And then once the filter is made, then that's where we talked about the scheduling coming in and determining where on the filtered nodes it can be deployed. A container can be deployed. It also gives you the ability to partition the cluster. As I mentioned with the tags, you can set up zones or storage or any variety of tags that you can think of to segregate your cluster. So prod stage dev is one where you could spin up 3 hosts that are prod, 3 dev, 3 stage. And then your deployment script would basically set an environment variable on your container saying a constraint is it needs to be in prod and it needs to be in the external zone. But for the most part, the main point of Swarm is to expose a variety of Docker hosts as one single endpoint that you can interact with. It does at this point in time only support a subset of commands. So basically you have everything you need to get by, but you do not have everything you need to get in and debug or whatnot. They are working on the exec support and a few of the other ones. Exec is the main one that's missing from here. Currently it doesn't work effectively, it just drops you out, and that one would be very handy to have. But with the rest of them, you are able to run an already functioning system fairly effectively. And it is only a proxy. It does not keep the containers running or anything like that. It schedules where it can go, and that's it. So you don't need to make sure that this Swarm daemon is up all the time. If it goes down, you're just unable to change what is existing. You're not down. These are the tags that we're starting with. So in order to identify which capabilities each host has, you would apply the tags to it. You can apply any number of tags, and you can use them in any combination in order to target the machines that you would like to get to. So you can say it needs to have SSD, it needs to be production, and it needs to be external, saying it if you want to create an edge cache node or something like that. Interacting with it. It's almost the same as with a single host, with one major exception and one minor exception. The major one is image management needs to be done outside. So DockerSwarm does not handle, at this point in time, explicitly pulling down an image to a backend host. If you go to start a container and the image does not exist, it will automatically attempt to pull it down in the background synchronously prior to firing up the container. That can be, problematic. If you have a 10 gig container and a 10 meg link, that command is going to time out in a bad way. And so the way that I've overcome that here is basically pull down images to the Docker host directly, and then everything is set up and ready to run. The other thing that I mentioned previously is that TLS is somewhat shaky in a lot of these tools. So if you're running a TLS-enabled cluster, some of these external tools may not work as you expect. I know specifically Ansible is broken. They do not support TLS, and it's a feature request, not a bug fix. And as well as the tool we use, Armada, does not support it out of the box either. And so we're hitting a few problems while enabling TLS. Big should in theory work just fine. I know it works fine with TLS enabled Docker, and it should work with Swarm. I personally have not tried it though. And the Docker CLI definitely works. So you're able to just use the Docker CLI, doing Docker PS, Docker run, all that stuff. And now with filtering and scheduling. So with filtering, there are a few different filters that are available. There are constraint-based filters, which are the tags that each Docker host is spun up with. So in order to hit that filter, your tags that you start a container with need to match the tags that are running on a Docker host. Affinity. Affinity means I want to start this container, and it needs to be on the same machine as either this other container or this image already. Since we don't handle the pulling of images, you can say, spin up a container only on a node that has this image already, otherwise fail or otherwise continue. Port filters, one static mapping per host. So if you are statically mapping your ports, you need to, technically you can't physically map two of the same ports on the same host. And so basically that's saying, say you have an 8080 map. You're mapping, you're firing up an Nginx container to act as your edge, and you're binding it to port 80 of the Docker hosts. Now, since you're bound to port 80 on the host, there's no way you can spin up another one bound to port 80. And so that's what this filter is. It says, oh, well, we already have something bound on this host, so we can't spin it up here. And that will eliminate that node from the scheduling, and it will move on to the next one. So if we have 3 nodes that are available in the filter, and all 3 or 2 of them have A, B, have a statically mapped 80 to 80 host, and you go to spin up another container that's an 80 to 80 map, it will see that Docker host A already has it, Docker host B already has it, so it will automatically schedule it on C. That will allow you to basically spin up static mappings as one-to-one as you want to do. You don't want to do stuff anyways. And then health filters. Is the Docker daemon responding and healthy? It basically just pings its port, and if it can interact with it, it hits the API on info, Docker info. If it returns on that, it's considered healthy. So once your set of Docker hosts, and let me back up a little bit. So what I'm explaining here is we're going to spin up some containers. How does Swarm handle that? So once Swarm has taken your entire set of hosts, it's filtered out the ones that do not match your tags, your constraints. Affinity, it filters out any that do not have your container or image on it. Filtered out any that do not, that already have your static port mappings, and any that are unhealthy. So now you have a set of hosts, say there are more than one here, that are available for filtering. That's where scheduling kicks in. Scheduling is determining on the available machines, which machine are we going to put this on. At this point in time, it only supports two methods that are built in: bin packing and random. Bin packing is basically fill up this machine and then move on to the next. How that is accomplished, though, is kind of sketchy. And so what you need to do is basically assign a constraint to each one of your containers, 2 constraints. How many CPUs it's going to use and how much memory it's going to use. So you're pre-assigning this. That's what it uses to determine how full a hypervisor is. So it's not actually reaching out to the hypervisor and looking at its resources or utilization or anything like that. It's saying you have scheduled 190 1 gig containers on this. I have 192 gig of RAM. We have room for 2 more. And it's taking into account CPU as well. Now, one of the main benefits of Docker is to pack your systems to a load of 100, more or less. But it's to pack your systems as full as you can get them. If you're presetting how much resources your machine could get, you're defining, you're cutting out a static amount of resources for this machine. So it sort of defeats the purpose, I think. The bin packing stuff is basically you need to statically assign everything, and it just determines, well, you said that there are 100 gigs running on here, well, we'll just put it on the next one. It's it'll work for places where you need that overhead and need to be 100% sure that you're not overutilizing your resources. But I would prefer to use my resources to 90 to 100% or 90%. And so this sort of defeats that purpose. I'm going in and calculating RAM again. I thought I was done with that. Random is pick a host at random. At this point in time, unfortunately, that's the best scheduler. It will just basically, out of the filtered nodes, it will say pick a here and just go here. Balance is in the works, but due to the conversation around the bin packing, basically over subscription and all of that, this has been a very long run PR. I wouldn't hold my breath for it. I would probably wait for the pluggable stuff. The other alternative is pluggable. And what they're looking at, they're first targeting Mesos and basically trying to make a pluggable infrastructure so that you can put in your own scheduler. And with something like Mesos, you do get the feedback from your hosts that are in there. You do get actual load, actual RAM, and you can get as complex as you want in your scheduling stuff without having to wait for them to write all the logic. The product's already ready. So I would say the best bet in going forward is wait for this pluggable infrastructure, pluggable scheduler, and utilize that, or go in the random. But the random is fairly random. So I deployed 5,000 containers to 5 nodes, and you do end up with 990s-ish to 1,010-ish. It does do a fairly good job of distributing, but it doesn't guarantee that they're distributed. Requirements. Not many. Basically, it's very similar to Docker. So you could, in theory, run this on an existing Docker host. You don't need to spin up any additional infrastructure. You could just run it on your same Docker host alongside your Docker data. There are some problems such as if the application you're running in Docker brings down that host, you then are unable to interact with the cluster to bring it back up. But if you're just playing around, it can run alongside your Docker host, and you just don't tell anyone about it. Like, don't point people out to use it. Fire it up, and you can interact with it while everything else still runs as normal. You're not going to change state in Swarm that Docker won't be able to catch up with or anything like that. The file or node-based discovery requires no additional services. So you don't need to run console or a key value store or anything like that. You can use one of these other discovery mechanisms that require nothing other than Docker and Swarm running. Health checks still work with static discovery. So, that means that a file-based discovery is going to work just as well as a console discovery. You're still going to have a dynamic list that health checks in and out. You may not have some of the additional features that you get with console, such as DNS lookup and all that, but Swarm doesn't necessarily use that. So you don't need it. You don't need it. You can set it up with a file like a list of your Docker hosts and their ports. It's basically a hostname : port. Pass that in as a file discovery. Health checks will check whether or not it's available, and then you have your cluster that is up and running without service discovery or key value, which can get a little more complex. The other issue is you need to build the Go binary right now. They're not publishing their binary, and I'm pretty sure that's because it's alpha software. So you sort of need a Go dev environment and a place to publish it. So I basically just have an Ubuntu box that installs Go and publishes it to S3 and pulls it down, which is fine for development. You probably don't want to do that in prod. You want to use something like Bintray or package it in RPM, if you will. Configuration modes. And I'm sorry, have there been any questions on the past 3 sections?
I have a question about container affinity.
Sure.
So does Swarm do anything to link between hosts?
No, so cross-host linking is something that will provide a great benefit to Swarm. They are not doing it in Swarm. They're waiting for it in the Docker binary itself. Okay. So there's a long-running issue on there and how they're talking about it. But basically, it sounds like from these guys, the second it's implemented in Docker, they will implement it in Swarm. And that will now give you, infinite ability. You no longer need to have the affinity or anything like that, right? If you can do the cross-host linking, then all of your restrictions are gone. And that, I'm very much looking forward to that. And actually, when that's implemented, that's probably when we'll drop it into our system right now. Right now, the cross-host linking is a big problem. it's a pain in the ass, and you need to. There's a lot of logic that goes into where you're putting your nodes. So say you have a MySQL node, a MySQL container that has a data-only container. Well, currently you can't really, unless you set up your filters so that you can target one machine, you can't really, or I guess Affinity will do it too. But you need to make sure that your data container and your MySQL container are on the same host. With cross-host linking, that goes away, and you're no longer concerned with what metal your stuff is running on, and only that it has accessibility to the other host. Yep.
So say that you wanted to build a cluster out of a set of heterogeneous machines,
Mm-hmm.
and you wanted to be able to access each of the resources on each of those machines.
Yep.
Could you just deploy the
So-
daemon on all of them?
So what I would do for heterogeneous machines, if you want to access each one individually, you would set your Docker host environment variable to point at that machine directly. And so that's how we would do the image management stuff. Now, say you have a heterogeneous collection of Docker hosts that are in the Swarm cluster. You would set up your tags to identify each machine and its capabilities or whatever. So say you have one machine that's like all CPU, one that's all RAM, and one that's all disk. You would fire the Docker daemon up on the CPU machine with proficiency equals CPU. The second one would be proficiency equals RAM. The third one would be proficiency equals disk. Now, when you're scheduling a job, when you want to fire up a container that say needs heavy disk, you say a constraint equals disk, and that will put it to the machine, or a constraint, what do I call it, propensity equals disk, or whatever I just tagged them with, and it would direct that command to fire up the container to the machine that has the disk. Does that answer your question?
Yeah.
Yeah, and like if you need to interact with them directly, like specifically one machine, then you would basically go outside of Swarm and say do your image management and stuff like that. But if you wanted to basically schedule it, it would go through Swarm. Constraints would be set on your heterogeneous hosts as to what capabilities they have, and your job would say, hey, I need these capabilities. And so it matches your job's capabilities with the Docker host capabilities and ships your container there.
So if you have a programmable GPU, or perhaps a set of them that you want to control on multiple machines, can it access those as well?
So Docker and GPUs, I don't know. I'm not sure. I've not gone into that. I don't know. So it's a function of C groups and LXC. If that stuff is included in control groups, in the kernel's control groups, you would. If not, you would not. But I would expect you would be able to access it, no problem. And I would expect a GPU cluster would not be out of scope for this whatsoever. I would expect everything would work the way you want.
So on the Docker commands that you basically fire at the hyper or the proxy of Swarm, does it aggregate all the results and provide you like meta information about where the responses came from? If you were looking at
It does not. And so it provides you with a response. One thing that changes in the response is instead of saying TCP/80 in your ports, it gives you a host name or an IP/your port. So that's a major difference I've seen in the output, and that's how you would determine how to access your host on the back end.
I have a question about how it does the discovery. So let's say you're setting up a cluster, you have a bunch of Docker hosts, you start Swarm on one of them, how does it know about the other Docker hosts?
So we'll get into that shortly, but it's basically, it's the, not the scheduler or the filter, but it escapes me now. Discovery mechanism. So it will be either a file-based one, which has a list of IPs, ports, or you pass them all in on the command line, or you reach out to a key value store, such as console or etcd or one of the other ones. Yep. And since it's only the Swarm master that needs this information, it's only one file to manage. You don't have to synchronize files across all the systems or anything like that. Discovery. So, very burning question, and good segue. Node discovery. Node discovery is passing in all of the hosts, all of the backend Docker hosts on the command line. So it's just a CSV or CSL, comma separated list of Docker hosts and ports on the command line. File is setting etc swarm cluster.conf to be the same thing. It's just a IP:port setup, and it will read through them, health check them, and create its view of the cluster from that file. Console, which is what I've been using, and I like it. It uses its key value store. It's not as dynamic as it could be. So basically, if you guys are familiar with console or whatever, it has two separate sections. It has a service registry and a key value store. The key value store is a traditional, like a Redis type deal, a key value store with no dynamic nature. The service discovery is much more dynamic, where it basically health checks anything that checks in. So you can register a service, console will then check that service and say, okay, you are good. Those health checks are very handy, but since Swarm uses console's key value store, you don't necessarily get the benefits of the service checks. The key value store is very static. Your Swarm daemons fire up, they insert themselves in the key value store, and they never really go away. Now, Swarm Master itself will health check them out, but it will never remove them from the list fully. And I think that's just a beta software thing, and I believe they are working on it. etcd behaves in the same way, and Zookeeper is as well. Just using it as a key value store. Your cluster may partition as needed with the Zookeeper stuff, but we all know how that goes. And then Token. Token is using hub.docker.com to create your cluster. I personally haven't used it, but you do a Swarm create. It gives you back a UUID. You then pass that UUID to all the other Swarm daemons that you may be running.
Is the discovery going to be pluggable at some point with a roller on?
I don't think so. I haven't heard talk about pluggability on the discovery stuff. Also, one other thing I see is they support the CLI, they support file, they support console, etcd, Zookeeper. I don't know of many others that I plug in there. So it does give you a lot of features, but I don't think that they're calculating that in. Scheduling strategy. So this is what we talked about a little bit ago. Bin packing is basically fill a host and move on to the next. Random, pick it at random. Balance is still under development, but the idea was with balance is to basically round robin and sort of one and then the next and then the next. But the semantics around packing are dragging that down, and it's going very slowly. And then Meso is still under development, with ideally it's fully pluggable. Scheduling filters, constraints. These are the Docker daemon tags. And these are set up, you set a set of tags per host. These tags have to match what your deployment script is using. They're called constraints in the deployment script, and basically you pass it as an environment variable. So when you would do a Docker run, you would do Docker run with all your normal stuff, -e constraint equals a tag that you would like to match. You can put as many of these in to get as complex as you want on the scheduling. Affinity, it's going to place a container on the same host that another container is running, so you can have affinity for a container. Say you would like to have Varnish running on the same host as Nginx for some reason. You would fire up Nginx, and then your Varnish container you would pass in on a Docker run -e constraint equals or affinity equals the Nginx container. With the port, don't duplicate the statically mapped ports. It's going to be hard to do even if you wanted to. Health, only schedule them on healthy Docker hosts. So it's not going to try to ship off jobs to a host that's not there. The job will fail. If there is a host, or your set of filters only match one host, that host is down. It's not going to put it anywhere else. It's going to return with, we found no place to filter your node, and return with an exit code of 1. Mm-hmm.
Health filter is just automatic, right?
It is. It's built in. You have zero control over how that works. So you can't get any kind of tricky business in there. Their definition of health may differ from mine, but luckily this is written by the Docker guys, and so I do trust their definition of health at this point in time.
Well, it's Docker health versus application.
Yes, yes. And so that is one thing to clarify, is that this does not handle anything in your application level. This is only setting up your platform on which to run your application. So you're right. You're unable to see whether a node is an application is healthy to determine your scheduling or anything like that. It just is the Docker host alive and up on its port. TLS enabled and disabled. Have any of you guys set up Docker with TLS? So TLS can be enabled with Docker, and it supports with Swarm as well. It supports both, and we're going to stay in the Swarm mode here. It supports both TLS between the client and Swarm, as well as between Swarm and the Docker host itself, so that it's a full tunnel. The way that this is done is you create a certificate authority, and you ship this the certificate authority's certificate and key with your hosts, as well as the certificate is generated from. Now, the way Docker establishes its trust is if a sorry, let me back this up. There's two classes of certs in this as well. So in your client to Swarm, you have a client certificate. And this is basically an extended attribute on your certificate that says I am valid for client authentication. So that client cert is used for you to connect to Swarm. The client cert, and on Swarm, it has a cert that's good for both for client and server capabilities. These are extended attributes that I just learned about a couple of weeks ago. Real fun. Now on the Docker host, those certs have only server attributes set. So you have 4 types of certificates here. You have your server type certificates, your client server certificates, your client ones, as well as your certificate authority. These all work together to develop your trust with it. And the way it is, you can run it in verify or no verify mode. Verify mode or no verify mode just means you have SSL on everything, it's fine, I can connect on 2376. Verify is where you get the benefit. Verify determines whether or not your certificates have been signed by the same CA. If everything has been signed by the same CA, you have established trust and you're able to communicate. If some of them have been signed by a different CA, then it does not work. So basically what I've done in our deployment is create a full CA just for this. And we cut server certificates for all the Docker hosts, 1 client server certificate for Swarm, and then 1 client certificate which we hand out to our clients. That client certificate is what the clients use to connect to Swarm, and the other ones that no one's interacting with, no humans are interacting with. So you can automate that pretty well and just get that stuff shipped out. And as I mentioned before, Ansible is broken. You're going to see this. TLS has been supported in Docker since day one, but like none of the tools have ever used it, and no one's ever really done it. You either do it with the local Docker sock in var Docker, or you do it over 2375 over the network port. So when you start getting into it, you'll find no one's like ever tried it. You're just like, oh, didn't anyone ever try turning on SSL? It turns out, no, they didn't. So there are some unexpected things in here, and this can get tricky. Tricky as in it could be a blocker for your deployment. If you need TLS, this could be a big problem, and we're actually dealing with that now. Outside of Swarm, but we're developing a production PaaS, and we need TLS to meet our compliance requirements, but a lot of the libraries and tools we use don't even mention TLS in their code base or SSL anywhere, and so we're hitting a few problems with it. It's just not quite as mature as it could be at this point. And then for extra credit, since this stuff is pretty tricky, it's much, much easier to build a system that handles all the thinking for you. So for that, you have a routing and service discovery layer. With that, it would look on your Docker host, you're running your Docker daemon, I'm jumping in a little bit, but you run registrator on your host that basically see all the Docker events that are coming in. They input container starts and stops into console, and then your proxies that direct your traffic to your application that's running on there pulls from console. So you always have an up-to-date list of your backends, your upstream backends in your proxy. It works with both the console health checking and the registrator stuff. So registrator puts it in, it sees it's in there, then console takes over, health checks it in. And then your proxies are running something called confd or console template that are basically updating its template and restarting Nginx or AJ proxy as needed. And that will give you the ability to have have an endpoint that is static, that you can always point stuff to, that you can use for DNS, that has a completely dynamic backend around it. So you do still have two maybe physical or virtual or at least statically mapped or statically IP'd machines for HA, and one they're running Nginx that constantly have their backend upstreams updated and are constantly reloading anytime that change happens. So you never have a dead upstream in your proxy config. And so this gives you the ability to at least from outside of the cluster, interact with it as if it were a single web server running Apache or something like that. It removes all the complexity of where did this go up, or which host did this get spun up on. Okay, I need to modify the Nginx config to match that. Oh, it went down, so I need to pull it out of my Nginx config. And so there's only two backends in there. The service discovery and routing layer, while it is a very complex piece, really reduces the overall complexity of operating this system. Any questions on that?
That's totally outside of the scope of Swarm, right? This is a kind of separate layer that you can implement if you'd like to.
Yes, correct. Yeah, this is not required for Swarm, but with a lot of the complexity and automatic things that are happening in Swarm, it's nice to have automatic stuff to handle that so you don't have to think about it.
And does the service discovery also, like let's say if your HA proxy node is on host 1 and your container spun up on host 2, does it cross route?
Yes, because HA proxy or Nginx is basically pulling down a full list of the backends with IPs. And so it has the IP of the Docker host and the port that it may be mapped to, 49,000 or whatever. You don't have to worry about it. It will handle all that. The registrator will pick it up, give it the service and its exposed port, and then your load balancing layer will take care of that. Cool.
That also allows you to do non-static map ports.
Yes, non-static map ports, which is where we all want to be. Not quite there. So here's an example Swarm service-oriented architecture. So this basically includes all the configuration stuff we just talked about, as well as the extra credit. So you have your hypervisor layer. Say 3 Docker hosts. They're Metal running a full Ubuntu. They have a Docker daemon running, your standard Docker daemon. It's listening to the network as well as your local socket. Registrator's going to use your local socket to watch what's happening. That's the only real way you can see what's happening through the Docker daemon is watch the socket. So registrator's listening at the file system socket, and it's listening to the network for any network requests. So that's how Swarm's going to come at it. And each daemon is started up with a set of tags that describe its capabilities. You can see here we've set status equals master, disk equals SSD, zone equals internal. It's also going to run the Swarm daemon. So this is not a requirement if you're using the file or node-based discovery. You don't need to run the Swarm daemon any other place than the one main place. With the console, it does require that you run the Swarm daemon on your Docker host as well. And so what it's in theory doing is health checking into that key value store, but it's not ever removing itself. So there's an open issue on that. But the Swarm daemon is up. It's pointed at the console key value store, and it creates a path in the key value store under Swarm with a list of all the servers that are up and running. In addition to Docker and Swarm daemon, it's also running Registrator. Registrator is also pointed at the console key value store at a separate path. So instead of /swarm, we'll have /services. It watches what's happening in Docker and basically is updating that registry with what has been started and what has been stopped. And so that maintains a list of your services, at least what Registrator sees. So it's not actually doing health checks. The console will do that. It is saying this container has been started on this port, on this node, and inserts it in there so that your template on HA proxy or Nginx can then point to it. And it's also running monitoring tools such as Datadog, InfluxDB, anything like that. So the way that I normally like to set up these Docker hosts is basically anything that all of the containers are going to use. I prefer to have that on the host itself and done in configuration management. Everything else should be containers. So InfluxDB, or rather collectd and the collectd InfluxDB proxy, as well as registrator itself and Swarm. These are all going to run on the operating system level. These are not containerized. And that's a personal preference thing that's definitely up for debate as to whether or not that's best practice or not. One thing I've seen is that when you have a cluster, say you have 1,000 nodes, if you have 3 containers per each just for supporting services, then your empty dead cluster has 3,000 running containers on it. Which, you could argue either way. But I like having anything that multiple containers are going to use on the host itself. You then have the cluster layer. The cluster layer is made up of all your Docker hosts and the Swarm hosts. So it runs Swarm, and it connects to the Docker hosts. It's what's providing your single interface to interact with the cluster. It must be able to connect to all the Docker hosts. Now, that doesn't mean that you at the edge have to. So you could say have Swarm on a 192 address and all of your other Docker hosts on a 10 dot address. As long as Swarm has an interface on that network and can talk to those hosts, that's all it needs. It does not require the end user to be able to access those nodes. So you can basically create a separate security group for all your Docker hosts and allow only Swarm to talk to it, unless you need the full images. But you can segregate it, and you don't have to basically open everything up. It handles the distribution of the Docker commands, not the proxying of network traffic. So any start, stop, create, run, all that will be handled by Swarm. The actual traffic that is being directed from your Nginx or HA proxy nodes, that is not going through Swarm. That's going directly into the Docker proxy, which is what exposes your ports. So even if Swarm does go down, your application does not go down. Okay. The service discovery layer. In this example, it's provided by console. Basically, it uses the key value store to maintain a list of active and running services. We create 2 sections, one for Swarm, which maintains the list of Swarm nodes, one for services, which maintains the list of all the services. That's what console template will look at, the services, to determine its upstream backends for routing, for its reverse proxy. And the routing layer. The routing layer is what ties it all in. So as I mentioned, you can have 2 here with statically mapped ports. They basically run console template and Nginx or HA proxy, and they're polling that key value store and actually they have a direct WebSocket open to it, so they're watching it. Upon a change, you can configure it, how long it's going to wait or whatever, but out of the box, each change it sees, within a millisecond you have a new file and your service, or your router, Nginx, has been gracefully restarted. Now that can be a problem with a high volume of changes coming in very quickly, but it is very responsive. Normally you'll want to set it to 1 second, so that you get a change that comes in, it lets it finish changing, and then we'll write out the template. If you do it immediately, what I've found is that, say there's an event where you're destroying 3 nodes, redeploying. So you're destroying 3 and bringing up 3 new ones. It can get stuck in a state of there are no nodes there, and it doesn't see the new events coming in. So you want to have some timing set in there. But basically, the full process is you, as a user, schedule a container to run. Through Swarm. Swarm finds a host to schedule it on. It schedules it on that host. Registrator sees the event. It updates console with the new service and the exposed port. On the proxy nodes, console template is watching that. It sees the change in console and says, okay, there are some new upstreams for this service. It writes out a new config, a new etc nginx.conf, and then does a graceful reload on Apache, or on Nginx. And so that will get you your new upstream in and any old bad ones out, so that you're never sending traffic to dead nodes. This routing layer is, I think, the coolest part that makes this like a usable thing. Because otherwise, you got to remember where the hell you put all this stuff, and that's one thing my coworkers will agree. I don't know where I put that thing. So that's how this would all come together to create a service-oriented architecture with DockerSwarm, fully dynamic and ready to go.
Quick question, does the, oh,
No,
sorry.
continue.
Does Registrator also handle all the deregistration from the service?
It does.
Stuff?
It
Okay.
does. There's a little bit of magic in there. Like for instance, if it misses an event and you restart it, or basically, say Registrator's up, you fire up a bunch of containers, it puts a whole bunch of stuff in the key value store. You now terminate Registrator, terminate everything else, start Registrator again. It gets a good view of what's happening. It updates it and projects its state up into the key value store.
How does it do that? Like, it just like scrapes like Docker PS kind of stuff?
Yes, I think that's what it does. Scrapes Docker PS. It's something like that, but it is able to gather its state in a dynamic way and update the registry with what should and should not be there. Now, there are some tricky things, like some operational stuff that came in. For instance, Docker and UDP don't go together very well. And so what happens is console requires both TCP and UDP for its health checks. So you'll get into a state, say you have your console agent up, and it's running, you need to redeploy it. So you do a redeploy, it tears down your container, and it's running a container. It tears down the container and brings up a new one. Well, this new one is now on a new MAC address, and so you have ARP poisoning right now. You have a bad entry in your ARP table. With TCP, it will fix that. It will say, oh yeah, this is a bad entry, it somehow resolves it at a very low level. UDP never does that. And so what you'll have is that health checks in on TCP, then health checks out on UDP. It constantly flapping, constantly flapping. The only way that we have found to resolve this is to basically run a contract-f. We're installing the connection tracking kernel utility, flushing the ARP table. So, we deploy a container, flush the ARP table, UDP fixes itself. That's a big problem. And so I'm hesitant to call the solution that we have working because it's completely asynchronous. We're basically and the way we do it is we have that a Docker container. This is a good one. We have a container that has that contract package installed. Its entry point is contract-f. And so we run it. We run this container after we redeploy a console agent onto a host. We deploy this container with not privileged, but we cap add net admin, and we're setting it to use the host network. So basically, we do a Docker run on this container. It has access to the host network. It flushes the contract, and then the container goes away. Now it fixes our problem right now. I can't say that's a fix though.
A fix.
It's a fix. It's a fix. So now I would propose that if you're using UDP, get it out of the containers and onto the host file system. As I mentioned previously, there are arguments for and against that, and it's basically the arguments against it are it makes it harder for you to redeploy your base infrastructure. And I know that all of us have, at least at one point in time, that was the biggest pain point, was deploying these goddamn VMs or hardware or whatever. Now, I don't see that as being a big problem. We have orchestration now that can cut you a new template, deploy you a new VM, no problem. So I don't see that as being complex. But some of my coworkers are still not convinced that redeploying the VMs is an effective way to do it. They're their experience has been it's near impossible to redeploy these things. It takes 2 hours. You got to spin up and configure and all that. And, I say it's easier to redeploy that than to have to deal with flushing our contract table. But there's still some discussion to be had around it. And I could be convinced either way. I'm not 100% dead set that we should be running the console agent on the host itself. I am pretty much dead set that we shouldn't be doing UDP in Docker. Console doesn't allow you to turn it off. So, we're sort of in a tricky place right now with that particular aspect. But, yeah, thank you. That was it. I do have a demo, but it's not super flashy, and it takes a long time. So,
I got a question.
Cool, go ahead.
So when you saw the POC from the guys at Docker the first time around, did they have some sort of use case scenario as to why you would consider this? Because it's the first time anyone was hearing about it, before anybody could really wrap their head around it. What was their sort of take on why someone would
Clustering Docker hosts.
Yeah.
Yes, that was the main thing. And honestly, I had thought about it since day one. Having to deal with these machines individually and explicitly, I found to be a very, pain in the ass. It's supposed to be a little bit more dynamic, a little more ephemeral. I want to dedicate a pool of resources to something, and I want to interact with one host. And they basically said that that was the use case, and it's to create a bunch of hosts together as one. They also said that it was to be used in combination with machine and compose, which they never went with the compose name, I don't think. It's still Fig. But basically, machine, Fig, and Swarm would all be all you need to run a Docker infrastructure. Your Docker machine would go out, configure the machine, Swarm would cluster them together, and then Fig would handle your orchestration later.
Did they have anything that sort of talked about like Core OS? I feel like there's some commonality between what Core OS is doing.
Oh, they didn't. So it was before the Rocket announcement. And
No, yeah, this would have been way before that.
yeah, I was heads down hacking that day. I was like, oh, clustering, finally. And so actually, that hack day, I was looking to create a Docker cluster. And so I was doing it with Mesos Marathon and Docker, the hard way. And so while I was hacking, there was that Docker hack day, and Victor comes up and he's like, oh, we have this new tool, Swarm. It creates a cluster of Docker hosts. I'm like, oh, wow. I dropped the Meso stuff and just basically waited. Well, I did finish the Meso stuff, and the TLDR on that one is it's very, very complex. Mesos, Marathon, Docker running together, and Zookeeper is a very complex system to maintain. I had a hard time with that. I had a hard time with that in comparison to this. This is literally, you fire up 5 Docker hosts, a Swarm daemon with a list of those 5 Docker hosts, and you're operational. You're ready to go. Mesos there's a few dots in there.
Few question marks.
Yes, yeah. So their main use case was clustering this stuff, and I did not hear about any of the Core OS interactions, or whether they're targeting Core OS as feature set or anything like that.
Have you played around with Kubernetes at all?
I have not. No. My understanding is Kubernetes is like Swarm with brains, but I have not played with it at all.
Yeah, because it seems like a lot of the same components, like there's like a Kubernetes proxy service that acts similarly to this like Nginx with console.
Oh, okay.
So they're kind of doing something similar.
Yep.
With that. So it seems like Swarm's like a dumb proxy for all the Docker daemons, and then with all these other pieces added on, they're trying to build this sort of system you can use to.
Oh, okay, and so they're including all the batteries with it, more or less.
Yeah, it seems like Kubernetes is really thinking about it like big picture and rather than like mashing up all these components. They're just trying to like build everything.
Okay. It does make sense. Now, as you saw, there's a lot of moving parts here or whatever. But us being DevOps types, I don't want that one solution that just solves all my problems. That's fucking boring. I want to patch together 15 ones that sort of don't do it and make it work. But yes, this uses not only a variety of technologies, but a variety of technologies outside of the Docker realm. So you got Realm, you got the console and registrator and all that. And like registrator is just like some dude, so there's a chance that could change. It would be nice to have everything all together and at least with a README. But right now, what I see is the complexity here is not so steep and so required that you can't get going with it. You can't play with it. You can get this up without any new hardware or anything. You just need to go get DockerSwarm. You get a binary, push that binary out, and you can go ahead and start playing with it.
It's in homebrew now too.
Oh, is it? Oh, nice. Yes, they have cut a 0.0.1 release as of the past week or so. Almost ready for prod. A couple decimal ones.
Is there any plan on, do they actually plan on ever packaging Swarm with Docker itself to become like an option?
So it will never be in the binary itself. They had a big discussion about that, and they determined that this should be outside of the binary. So we'll never be in that same Go binary. Whether or not they come up with something, because right now I think, I know we installed Docker with just getting a binary. We wget a binary. So if they were to package that, I would see no reason for them to not include Swarm. But I'm not sure how they intend on packaging this stuff for Pro. So. Cool. Any other questions?
Awesome, thanks, Matt.
Thank you. Thank you. And this is up. I'll post these links, or I'll post the link to this slide presentation in the meetup. And these links here, I wrote a whole bunch of blog posts that cover all this content. And actually, it's probably fewer uhs and easier to follow, more logically laid out. But there's 4 blog posts that cover all of this stuff, as well as some more. And also there are some related links, such as the DockerSwarm GitHub repo, registrator repo, console template repo, all that stuff. As well as how to generate the TLS certificates. I wrote a nice little blog post on that, because that was stuff that, after 10 years of doing this, I had never seen that once. I was like, it's fun. Cool. Thank you, everyone.